Okay, guys, so this is problem 49 in your book. This was the one where you were trying to use evidence from a bullet shot to pinpoint the location of the shooter. The information that we know in this problem is that the bullet passed through the window here and then was implanted into a wall 6.9 meters behind the window, and that the bullet fell about half a meter from the point of entry into the window to the point of impact on the wall. And we need to try to use these two bits of information, how far it traveled from the window to the wall and how far it fell. We're trying to use those two bits of information to figure out how far away was the shooter and how high up was he. If we can find those two bits of information, we'll be able to identify from the top of what building did the shooter fire from, and we might be able to go over to that building and find more evidence or whatever we need to do. So I'm going to add some information to this diagram. I'm going to call the point where the shot was fired point 1. I'm going to call the point where the shot impacted the window point 2. And I'm going to call the point where the bullet embedded into the wall as point 3. Because we've got 3 different things going on in the problem, it would be a little bit confusing to use initial and finals. So we're just going to use 1, 2, and 3 to split the problem up into the 2 segments. Okay, so that's all the information we have. There's 2 ways to solve this problem. In this video, I'm going to show you how to solve the problem numerically by starting with any value that you can possibly figure out and then continuing from there. In the problem, they tell us the speed that the bullet is fired at is 340 meters per second, and it's fired perfectly horizontally. So that means that we actually know the horizontal velocity. If I look at the displacement between points 2 and 3, so that would be the distance between the window and the wall. That displacement would be equal to the horizontal velocity times the amount of time that passed between traveling from point 2 to point 3. So I'm going to use this equation to figure out how much time passed from the point when the bullet passed through the window to the point where the bullet embedded in the wall. If I solve this equation for t, I'm going to get this here. If I substitute the values I know, we were told in the problem that the distance between point 2 and 3, the window and the wall, was 6.9 meters. And we were told that the bullet was fired at 340 meters per second. If I use a calculator here, I'll find that the time is 0.02 seconds. So I want to remind you that this is not the time of flight, this is just the time it took for it to go from the window to the wall. Alright, what can we do next? Well, let's call this step 1. So now that we have the time from points 2 to 3, we can figure out actually the velocity that the bullet had when it entered the wall. The way we can do that is say that the height at point 3, which is the final height that it was embedded in the wall at, the height at point 3 is equal to the height at point 2 plus the velocity in the y direction at point 2 times the time from 2 to 3 plus the acceleration divided by 2 times time 2 to 3 squared. So all we're doing here is really figuring out the velocity. We know that the height, when it embedded in the wall, we're just calling that zero displacement. The height that it hit the window at was given to us. That was 0.5 meters above where the bullet impacted the wall. So we know those values. We just found time 2, 3. Acceleration is gravity. So this equation will allow us to find out what is the velocity in the vertical direction of the bullet as it enters the window at point 2. So I'm going to solve that equation really quickly. If we plug in values here, we'll get 0 meters. 0.5 meters is where it was when it impacted the wall, or sorry, the window. This is what we're trying to find. We just found that that's 0.02 seconds plus negative 9.8 meters per second squared divided by 2 times 0.2 seconds squared. If I solve that for Vy2, I'll get negative 24.9 meters per second. So now I have another value that might lead me to the answer. The next step is again to figure out what can I do now with the information that's given to me. Well, I know the time from 2 to 3, and I know the velocity at point 2. So why don't I figure out the velocity at point 3? So again, what we're doing here, we know the velocity that the bullet entered the window at. We know how much time it took for the bullet to get from the window to the wall. So let's figure out what velocity in the vertical direction did the bullet impact the wall at. So as we're, so we can use the time to figure out the velocity, the vertical velocity that the bullet impacted the wall at. So the equation that we would use here is the velocity at point 3 in the vertical direction is equal to the velocity at point 2 plus acceleration times the time that passed, which is the time from 2 to 3. When we do that, we can plug this in, and we'll get Vy3 is equal to negative 24.9 meters per second plus negative 9.8 meters per second squared times the time we found, which was 0.2 seconds, and that equals negative 25.1 meters per second. Okay, so we have a decent amount of information now. We know how much time passed as the bullet went from the window to the wall. We know the velocity of impact of the window. We know the velocity of impact of the wall down here at Vy3. So the next step would be to try to figure out the total time. So what we're going to do here is we're going to try to figure out how much time passed from point 1 to point 2. And then we can add that to the time from 2 to 3. To figure out how much time passed from point 1 to 2, we can use another bit of information we know. Since the bullet was fired directly horizontally, the initial velocity was 0 in the vertical direction. So I'm going to do the exact same problem here that we did just a second ago. So our next step, or step 4, is going to be the velocity in the y direction at point 2 at the window is equal to the velocity it was fired at, which is the vertical velocity at point 1, plus the acceleration due to gravity times time, but this is going to be the time that passes from point 1 to 2, the point when it was fired to the point when it hit the window. If I solve for time here, I'll get that the time from 1 to 2 is equal to the velocity 2 minus vertical velocity 1, all divided by the acceleration. I know these values. Velocity 2 we just found, it was negative 24.9 meters per second. The velocity it was fired at in the vertical direction is 0 because it was fired horizontally, and gravity is negative 9.8 meters per second squared. So the time that passed from point 1 to 2, firing to hitting the window, is actually 2.56 seconds. Now what I can do is I can use the total time. It from 1 to 3 would just be the sum of the two times I just found, so 2.58 seconds. I can use this total time to figure out how far the bullet fell altogether, and that'll give me the height difference between the bullets embedding into the wall and the top of the building, and that was one of the quantities I was looking for. So if I do that really quickly, Y3 is where the bullet landed at point 3 in the wall. Y1 is where it was shot at point 1. Velocity Y1 times time 1 to 3 plus the acceleration divided by 2 times the time 1 to 3 squared. So again, we know all of these values except for the initial height, which is y1. So I can solve for that. Y1 is equal to the height, which is equal to, and I'm just doing a little bit of rearranging, subtracting everything to get y1 by itself. Okay, and then if I plug in the values that are given to me, the height at the wall is 0 because that's where we're measuring from. The initial velocity was 0 in the vertical direction. Time was 2.58 seconds. And then over here is what's actually going to give us our answer. Okay, and then when we solve that, we're going to get that the height was 32 meters. So the shooter was 32 meters above the bullet impact in the wall. That gives us some information and will direct us towards where we need to look. The next thing that we can figure out is the distance, D. How far away is the building from the other building? So we're looking at the distance, or the horizontal distance between point 1 and point 2. To do that is rather simple. So this will be the last step, point 6. D is equal to x from point 1 to 2, which is equal to the horizontal velocity times time 1 to 2. If I plug in those values, I'm going to get 340 meters per second times the time from 1 to 2, which we figured out was 2.46 seconds. If we multiply that, we're going to get something around 863.6 meters. Okay, and those were the two values that we were asked for. Using that information, it'll give us a better idea of where the shooter took his shot and hopefully solve the case.